Good day everyone. So now we will be talking about the Pascal's triangle. So what is Pascal's triangle? It is a triangular pattern of numbers that represents the coefficient in a binomial expansion. Each row of the triangle begins and ends with the number 1. And the number inside the triangle are formed by adding the two numbers directly above them. Because of this pattern, the triangle is symmetrical and the nth row always has the n plus 1 element. And Pascal's triangle isn't just a nice pattern. It is very useful, and it is commonly used in probability, algebra, and combinatorics. And for example, it helps us find binomial coefficient, and it can be used to estimate probabilities like predicting the outcomes of a coin.
Now let's learn the brief history of how Pascal's triangle was developed. In the 11th century in China, Xian devised one of the earliest triangular arrangements of binomial coefficients. He used it to simplify computations of powers and roots, and it became the foundation of the Yang-Hui triangle. While in Persia, Omar Khayyam studied binomial coefficients and combinatorics, similar to Pascal's triangle. In Iran, it is sometimes called the Khayyam triangle. Then, in 1623 to 1662 at France, Blaise Pascal rediscovered and studied the triangle in Traité du triangle arithmétique. He linked it to probability and binomial expansion, leading to its name Pascal's triangle. And then, 1665 to 1676, Isaac Newton extended Pascal's ideas into the general binomial theorem, which applies to any real exponent, linking the triangle to modern algebra and calculus.
Now, let's apply Paul's method on one of the examples using the Pascal's triangle. Now, our example here is a teacher wants to form a group of 4 students from a class of 8 students. How many different groups can be formed? So, we have 3 understandings on this. First, select 4 students from the total of 8. Now, number 2, order doesn't matter since the group is the same regardless of the selection order. Now, number 3, therefore, it's a combination represented as C, 8, and 4. Next is we're going to plan. Since the order does not matter, we can use the combination formula while using the Pascal's triangle. Now, on how to locate or find on where we can start, we have 3. Start with draw the Pascal's triangle. Next, locate the row for the total students. Row is 0 as the start. We have 8, so we will start at the row number 8. And next, find the position matching the group size. Position 0 as the start. Now, this will be further explained once we carry out the plan in the next part.
And this is how we carry out the plan. Since the teacher is choosing 4 students from 8, this corresponds to the value in row 8, position 4 of Pascal's triangle. We can locate the 8th row in Pascal triangle by counting from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. When row 8 is written out, it appears as 1, 8, 28, 56, 70, 56, 28, 8, and 1. And we can locate the element of position 4 by counting starting from 0. 0, 1, 2, 3, 4. Therefore, the number of different groups of 4 students that can be formed is 70. And now we are going to check if our answer is reasonable. We're going to use the formula of combination, which is C is equal to n factorial over r factorial times n minus r factorial, where n is the total number of students and r is the students chosen at once. And if we substitute the numbers, we get 8 factorial over 4 factorial times 8 minus 4 factorial. And we can write it down as 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 4 times 3 times 2 times 1. And we can cancel out the 4 factorial since we have it in our denominator. And we get the answer of 1680 over 24. And the answer is 70. Now we can see that The results of the formula is same to the answer found using the Pascal triangle. Therefore, the answer is reasonable.
So now, I will be presenting a short reflection, attestation about Pascal triangle through the acronym Pascal. Let's start with the letter P. Pascal triangle shows amazing number patterns. It reveals hidden patterns that increase as you add more rows, helping us to see how numbers relate in growing structures. And next is the adding the two numbers above each value shows how simple ideas can grow big. So each number in the triangles comes from a simple rule. Adding the two numbers above it show how small ideas can create bigger results. And seeing its organized structures, understand how math connects meaningfully. The triangle layout is neat and patterned, which help us clearly visualize how mathematical ideas are connected to one to another. And connection between number show concepts used in many math fields. This connection explains important concepts like combination of binomial, coefficient, and more advanced math topics used in many fields. And applying Pascal triangle, we can use the triangle in solving math problems, probability patterns, and even everyday decisions, showing its practical beyond just learning. And learn from it. Studying Pascal triangle improves logical reasoning problem solving, and deeper mathematical thinking. And that's all for Pascal triangle.